St. Just. Welcome back to Just Coded. And today we'll be solving 217 contains duplicate. So this is an easy problem, and to quickly read the description to you, given an integer array nums, return true if any of the values appeared at least twice in the array, or return false if each element is distinct. So looking at the first example, we can clearly see we return true simply because one appears multiple times inside the input array. And for the second example, this is false because all the elements in the array are distinct. And for the third one, we see that all the elements appear multiple times inside of our input array, and so we return true. And to walk you through my explanations, first I'll be going over the base cases. And with the base cases, these are typically things that I ask the interviewer, since all the information on the left isn't always going to be provided for us. So the first question I have is, will there always be a valid input list? The second is, will the input list always have only numbers? So meaning, can it possibly contain non-numeric values such as characters, special characters, or operation keys? And for the third one is, the list always going to have all numbers from smallest to the largest, right? And with this, you can also add like what could be the largest size of the input list. Usually they would probably say 1,000,000, which is fairly large. So this meaning, are we going to have all the values from 1 through 10? 10 being if it was the largest. So are we going to have 2, 4, 5, 6, everything inside? And so with the first approach, the time space complexity is both linear O of n, and what we'll be doing is to create a set and iterate through the input list while adding each number that we've seen into the set. And if the value that we're about to add is already in the set, we can immediately return true, meaning we found a duplicate value. Else, if we iterated through the entire input and found no duplicate values, we return false. And for the second approach, this space complexity is a lot better, being constant O of 1, but the time complexity changes to n log n. And this is because what we'll be doing is first sorting the input list and then checking if the current number is the same as either the previous or the next the next number. And if it is, we know that there's a duplicate value and we can return true. And if at the end of the loop we find no duplicate values, we return false. And for the third approach, the simplest one, which is both the time and space complexity being linear, O of n, is to convert the input list into a set and compare its length to the original input list. And if the links differ, that means there was a duplicate value in our original input, since sets only contain unique values, and we return true. Else, we return false. Now we begin by writing the code, which is first to create a set. And for the numbers in nums, if number in scene, we just immediately return true. Else, what we would like to do is to add that number into our scene. And if at the end of the loop we don't return true, meaning there's no duplicate values, we just immediately return false. Give this a run. You see that it works. Now we're going to submit it. Looks like it places fairly well, beats 71%, which is good. And for the second example, which is to first sort the input nums.sort, and for I in range, starting at 1 to the length of nums, if nums.I minus 1, the previous number, is equal to nums at the current number, we return true. Else, we simply return false. And remember, this is n log n because the sorting is log n, but iterating through is n. So we can quickly see if this runs, passes all the test cases. Great, it does, but it places fairly at the end because most of the solutions are of linear time. And for the last solution, which is the most simplest one, is to just simply return the length of our current numbers not equal to the length of converting our current numbers into a set. So if they're not equal, this statement returns true. Else, they are equal, it returns false. So let's get this to run. And it passes all the simpler test cases. And now it passes all the test cases. Placing fairly high beats 40%. Our previous one beat 70. The best one beat 70. But yeah, so thank you for coming and watching this video, and hopefully you did learn something today. I will continue to post more videos. I plan on posting videos in C++ as well, as I am relearning it for some of my classes. And I just want you to subscribe and turn on your reminders and notification bells on. Thank you and have a nice day.